So in conclusion, these are the various differences between the principles of positive displacement pump and non-positive or rotor dynamic pump. So the fluid is trapped inside a closed volume and discharged through the outlet in case of a positive displacement pump, and in case of a non-positive displacement or rotor dynamic pump, the fluid is given a momentum by the rotary element, that is the propeller or impeller, and then that directs the fluid towards the outlet. For incompressible fluids, the fluid displaced by the moving element, that means the piston or plunger or gear, etc., will be equal to the fluid pumped out through the outlet. That means if the fluid is not compressible, then whatever is the movement of the piston inside the reciprocating pump, suppose, that much fluid must be expelled out through the outlet. However, that is not the case in case of a rotary pump or rotor dynamic pump. So in that case, if the impeller is moving very slowly, then there may not be any discharge at all, and even if it is moving fast, some fluid will move through the outlet, as we have seen in this kind of a casing. If this is the impeller, some fluid may move outward, but some fluid may simply keep moving inside. So it's not that all the fluid which is displaced by the impeller or propeller is actually discharged through the pump. Then closing the outlet of a reciprocating pump or positive displacement pump is actually quite dangerous, because if suppose inside a piston, if the piston moves and it is forcefully moved to this location, now the volume of fluid which was earlier this much now has only become this much. So that much fluid must be released through the outlet, and if the outlet is closed, the pressure can increase by a lot inside this piston, and if the piston is not strong enough, if the cylinder is not strong enough, then there may be possibility of explosion or bursting of the pump casing. However, in case of a centrifugal pump or a rotor dynamic pump, it is not that serious, but still it is considered dangerous, because although the fluid can keep moving inside the casing even if the valve is closed, because we are giving it extra energy by rotating it by means of electrical energy, and therefore it will cause heating of the fluid, and at some point it can also burst. Then discharge in case of a positive displacement pump is not continuous. However, as we have seen in case of multi-cylinder pumps, it can be made fairly continuous. However, in case of a rotor dynamic pump, either propeller or impeller pump, it is generally continuous. So these are the basic differences between the positive displacement pump and rotor dynamic or non-positive displacement pumps. So we'll discuss each of them separately in different lectures. Thank you.